probably saw that because we had the arcade cabinet set up, similar to what we've got now. If you guys haven't dropped by my booth, my shameless plug is please drop by the booth. We went through quite a bit of effort to come here. I come here from Idaho, so not too terribly far, but a decent distance. So I actually prepared 2 or 3 different presentations based on the audience here. So I'm going to do kind of a quick survey while he's finding batteries, and that will decide which presentation I give. So, who here has experience with development? Raise your hands. Keep your hand up if you've been doing game development. Okay. Okay, thank you. As far as development is concerned, who here would consider themselves like a really kind of raw beginner for development? Okay, I see a few people that are beginners of life because they're so young. It's good to see you here. Okay. So yeah, I think what I'm going to do is just kind of the entry level. So please forgive me if the presentation for some of you might seem a little boring at first. For development, we're going to be talking about things like what are functions and what are variables and so on. But I hope that all of you can see how game development can work with the Love 2D framework. It's kind of my Swiss Army knife for 2D games. It's a good framework, it's open source. The only thing I have to say is that the Love 2D community can be a little hairy at times. I've been working with them for a few years now. They're improving, but a lot of them are still rather immature, but doesn't get better. So just keep that in mind if you go reaching out to the community for help. They'll likely help you, but they might do it in a very offensive way. Perfect. Yeah. Okay. That being said, they're really good. They've written some libraries, and I'm going to go from start to finish, and we're going to make Pong. But I want this to be very interactive. Okay. I kind of made a boilerplate. I sat down and said, "Can I actually make Pong in 50 minutes?" I sat down and made it in about 30. So we do have a little bit of time to discuss things and try different approaches. The goal here is to have you guys know how to make a basic game, whether it's Pong or Breakout or something else, so that you guys can take this knowledge and grow upon it. Does that sound like the presentation you guys want to hear? Okay, good. So I need a way to plug in so people can see my screen. Is there a way for me to do that? Who's figuring it out? But we do have batteries now. Yeah, so that's good. Yeah, I was going to be like, line 1. It's function. Okay. Now, if you guys have laptops, I see a lot of them here, feel free to follow along. You can download the framework from love2d.org, LOVE2D.org. And everything we're writing works quite nicely with that. Hope for the best. We all eagerly look at the screen. Is it display board? Is that what they call it? Display board? So they do have HDMI.
Oh, there's something.
It's gone. Please stand by. We're experiencing some technical difficulties. Anything? Do we need to push the buttons again? There we go. Buttons. Okay, so I'll adjust the zoom here, maybe, possibly. I don't know how well this is going to work, but I'm assuming that what I'm seeing is there. Okay, so what makes Pong a game? I mean, what's the difference between like a game and an application? An objective. An objective, right? So like in Pong, you got this objective, which is what? I know this is really basic. There are some young people here that may not have played Pong. Okay? So, what are you trying to do in Pong?
Hit the ball back.
Hit the ball back, right? So the ball bounces around, okay? So the first step when you're trying to make a game is you want to visualize your idea and actually understand what it is you're trying to do. I have gone to so many people and I've talked to them and they say, I want to make a game. And I say, what do you want to make a game? And they say, I want a game that's like this massive multiplayer, whatever. And they tell me all these great ideas. And I say, okay, where are you starting? And they don't have their objectives defined enough to know where they're going to start. Okay? That's what makes Pong such an excellent hello world game app. Because it's simple. It's easy to define. There's a ball. If it goes on the left side without being hit by a paddle, player 1 doesn't score point. Player 2 does. If it goes out the right side of the screen, right? That's really all it is. Okay? So in this game that we're going to make, Pong, we've got a few sections we're going to break it into. We have initializing things. It's how things start. Okay? We have drawing what we've initialized. Granted, you don't necessarily have to have a game draw anything on the screen. I find it beneficial. There was one game I saw where you wear headphones and you would navigate based on sound through the game. So you don't always need that, but most games you're going to be drawing something on the screen. And then you need to have some sort of interaction. So things need to move, whether you're making something move or the game is having to move. And then usually you have some sort of user input, except for the game Mountain or whatever that was called. There wasn't really any user input on that one. But okay. And then if we have some time, we're going to add some juice, which is like particle effects and sparks and all that kind of stuff. But that's only if we have time, because that's not really part of the game. Okay, that's not going to impact gameplay as much as just make it more attractive to look at. Okay, so I've got kind of a boilerplate here that goes over various chunks of code that we're going to need, and then I've also grabbed a library called Lovebird, which is absolutely amazing. I recommend you guys put it in all your projects if you're using Love2D. It's just amazing. I'll show you how it works in a minute. Okay? Excuse me. But main.lua is what's required in Love2D for your game to start. This is where everything begins. Okay? So there's a few key functions in it, and that's these first 3 functions that I've got. So we've got love.load, which is called almost immediately. After the love engine itself is fired up, it fires up love.load. So that's typically where you're pulling external libraries, initializing some variables, making spots to store things. That's where you put that sort of information. Then you have, love.update. Love.update is what happens every frame at the beginning of the frame. So before anything is drawn, this is called. Okay? This is typically where things are going to be moving about. Okay? In fact, if you're moving things about and it's not sourcing from love.update, you're doing it wrong. Okay? And you notice love.update has an argument being given to it, which is dt. That is the delta time. That is how long your frames are taking to render. Okay? It is the great normalizer. We'll talk about it some more in detail. It's very, very important. But love.update accepts dt. And then the third function is love.draw. And this is called after love.update, every frame, to actually stick the stuff on the screen. Okay, everyone with me so far? Does this make sense? Any questions?
Yep.
Did someone say yep or no?
Yes. Can you hear me?
Oh, well, that was kind of an interesting sort of conversation. I can't answer the questions for the person on the phone there. Okay, so I put some common things in here, but we're going to step through them one at a time and explain them. So the first thing I'm doing is I'm saying how wide is my screen, or my game area. You'll notice that all the API calls I'm using are love.something. Okay, so in this case, love.graphics.getWidth returns the width of my window. Because I don't want to be drawing stuff outside of my window. Right? I mean, it doesn't make sense to have the game off the window. It needs to be where people can see it. So I'm determining my width and height of the window. And I'm giving those variables. So I've got width equals that, and height equals get height. Okay? In Lua, pretty much everything is global by default, which is kind of backwards from a lot of other languages. Okay? So I can use width anywhere and height anywhere. If you want something to be local, you actually pass the local before declaring a variable. And we'll explain why you want to do that in a moment. But I don't want to sidetrack myself. And then you have players equals this weird curly brace thing. That means it's a table. Anyone know what a table is? Okay? Who wants to tell me what a table is? Yes.
Lua is only data structure.
It's a what?
Lua is only data
Yes.
structure.
Everything in Lua is a table. Okay? But you can use tables for, I mean, since it's Lua's only thing, you can use it for just shoving information into. So we needed a spot to keep track of players. So I'm saying, hey, players, here you go. All of your information is going to be over here. And then I said on the next line, we need to keep track of the ball, right? And I thought, you know, it might be fun if we have multiple balls. So I said, okay, balls need to be tracked over here. And then I'm running a function called add ball, and then I'm in. That is all happening immediately when I run the game. Then it moves on to doing my update, and it's going to be doing my lovebird magic here. And then it moves on to drawing. So let's run our application real quick. And if you have questions, feel free to interrupt me. Let's see, where's my Openwest? There we go. So to launch my game, I'm just dragging my presentation onto the love icon. In Linux, if you're using Ubuntu, there's a nice PPA that has the latest version. That's what I'm typically developing on. Just do love dot in the folder or whatever. I'm going to launch it. And you see here, I have a ball. That looks so amazing. Okay? It's an 800 by 600 window. And where this is being output is in my love draw. Once again, I'm saying I'm going to use the love graphics module to print width at 0, 0. So top left. Okay? Everything they taught you in school with, you know, the y-axis being at the bottom, that's all wrong. It's at the top. Okay? Okay? And then I said I want the height 10 pixels beneath that. So the love.graphics.print argument says you say what you want it to print, and it'll use whatever font you set. By default, it picks a same one. And then you tell it the x-coordinate and the y-coordinate. Everything in love kind of follows this pattern. Okay? So I use it for the height. And then I say, let's take all of my balls here, and I'm going to draw a circle. It's a filled circle. It's x and it's y, and it's 20 radius here. Okay? So here's where things get really fun for people that are new to development. That lovebird thing that I stuck in there actually lets me interact with my code through a web browser in real time. Okay, so I'm going to fire up our game. You can all see that's the most amazing thing. And then if I go here and I go to localhost 8000, let me make it bigger. You can see here that I have my table for the balls, and I can browse in and I can see its direction, its x and its y. So it's at 200, 200. Can you see that? And now we can start to actually tinker with things. So I can say I want x to be equal to 400. Okay? You guys see that? Okay. So this is really useful when you're trying to figure things out, because it'll kind of teach you the syntax, and it will let you change things and see what's going on. Okay? Everyone with me so far? Okay. Hopefully I'm going at the right pace. If you guys all feel I'm going slow, just like look at me angrily and I'll speed up to be less descriptive about certain things. Okay. So let's look at how that ball was created. Up here I call the add ball function, and I'm giving it an x and a y coordinate. Down here I declare the function. So I say I'm making a function called add ball. And this function expects two things to be given to it. These are called arguments. Okay? An x and a y. Inside of that function I say, I'm going to make my little ball object. And it's got an x coordinate, which is x, that's passed in. A y coordinate, which is y, passed in. A direction, which is a random direction. Okay, and I'll explain this crazy thing I got after it later, but just know it's a crazy direction. And then I insert the ball that I just made into the balls table. That way we can have as many balls as we want. So if I go here, and I duplicate this line, and I say 400 by, or 400, 400, what's going to happen? What?
It's going to put another ball in.
It's going to put another one in, yep. So, I'll go here, and I will exit our game, and Lovebird is smart enough to reconnect once it goes. So now we've got two balls here. Okay? So by using a table to keep track of these entities in the game, we can say, okay, we've got multiple balls. We've got 4 balls, or we've got 5,000 balls. Love to do these pretty quick. I've got a game where I'm simulating bacteria that I'm building, and I can have about 2,000 different bacteria with physics like blood flow, moving them around and such, and it doesn't choke at all. It's very performant. So you can do quite a bit with it. So let's go back and remove this other ball here, because we don't need that. And let's make it move. Now you see here in the love.update, where we're supposed to make things move, we're not really doing anything with it, right? We're not changing any variables, not changing any placements. So what we're going to do is we're going to use a for loop, which
where did you say we could get this code to do it ourselves with?
Well, love2d.org is the framework.
Right.
And then actually, I don't think I actually made a public repo. I'm sorry, I made a private repo for this, and that's not going to do anyone here look good. I'm sorry.
Okay.
I can give you the code after.
Okay.
Or you can go through, because it's just a boilerplate that I did, so you can go through and mess around with this if you'd like. And I'm going to go through and I'm going to say for KV, which means the way I reference it, key value. So which one is it in the list, and what does it contain? In the balls. So this is going to go through all of the balls that we've got. And we're going to make it so that it will take V, which is the current ball that we're looking at. And what do you guys think would happen if we said v.x equals v.x plus 1? What do you think would happen? It would move by 1. But not just once. Love.update is called every single frame. Okay? So in this case, it would move, if I'm going at 60 frames a second, it would move 60 pixels to the right. Because x is increasing. Right? And if I changed it to -1, it would go to the left. Okay? So this is where DT becomes important. Because my computer is a different power than like one of those guys that makes these ultimate gaming rigs, you know? And my frame rate might be 60 frames a second, but his frame rate could be 300. So what happened is, the ball would move to the right at 60 frames a second for me, but it would move to the right at, or at 60 pixels per second for me, but it would move to the right at 300 pixels per second for the other gamer. And that's not necessarily what I want. That would be one wicked fast Pong game, and no one would enjoy that. Okay? So that's where DT comes in. So if you take a value and multiply it by DT, it will scale that based on how fast the machine is rendering frames. Okay? So I'm going to make this times 100 so we can see better. So now I've got v.x equals v.x plus 100 times dt. So per second, whenever you multiply something by times dt, think in seconds. Per second, this is going to move to the right, every ball, 100 pixels. Okay? Does everyone think this is going to work? Or do you guys not have any confidence in me, or tons of confidence, or it's going to work? You gotta have confidence, people. Because 90% of the time I code something and it doesn't work. But I'm pretty sure this one's going to work. Good. Okay. So the ball moves to the right, and it keeps on going. Yeah. And in fact, if we go back to Lovebird, you can see that our ball is continuing to move to the right. Okay? Computers don't know what you mean for it to do. You have to tell it. Yes, everyone looks off in the distance. Yes. Computers don't know what you mean for it to do. So you have to tell it exactly what you want it to do. So let's start putting some boundaries here. Okay? So we're going to use what's called an if statement. So we're going to say if v.x is greater than, how about our width? Because if it's moved off our screen, we want to do something, right? Okay, what should we have it do when it moves off to the right of the screen?
Go back.
Okay, go back, or do you want to bounce?
Explode. Or
We need to invert the number.
We need to invert the number. Okay. Okay, so if we're going to invert the number, we need to have like a direction that's at play here, right? And you notice that I already made this lovely ball.dir, right? Okay, so let's actually change my crazy function here to be 1. And it's going to move at, well actually we'll say dir is 100. And we're going to use v.dir. Does everyone see what I did there? Everyone understand that? Okay. So we're now, instead of saying it goes 100, we're saying it goes its direction, and it happens to be 100 when it started. All right? So if v.x is greater than the width, what are we going to do?
We're going to negate v.dir.
Yeah, we're going to bounce it, right? We're going to reverse it. So we're going to say v.dir equals v.dir times -1. All right? So now what do you think is going to happen?
Bounce and run off the left side of the chain.
See, now people are talking. This is good. This is good. So let's see what happens. This is great, right? We're through the hard part already, right? Okay. So now it moves, and what's going to happen now? Okay. So we've got to do something to control the other side, right? So we can actually extend our if statement some. So we can say, else if v.x, what am I going to put here, guys?
0.
0. If it's less than 0?
Less than what?
Well, less than width wouldn't necessarily work because the width is the whole thing. It's always going to be less than width,
It
right?
starts on 0 and then moves to the other side, right?
Yeah, yeah. Then we're going to say v.dir equals v.dir times -1. Okay, so the first thing it's going to do is it's going to say, hey, am I greater than the width of my x? If I am, turn me around. And it's going to say, if I'm not, let's check the next thing. Am I less than 0 on my x? If I am, turn me around. Right? You guys think this is going to work? See, you guys you're gaining confidence. This is awesome. Okay, so now we got this lovely ball just moving here. There it goes. And it should bounce back in a moment. I probably should have made it go faster. All of our time's going to be spent watching this ball move back and forth. So what'd you do? Well, we watched the ball move back and forth. Okay?
Real quick, does everything end with the end statement? Just kind of.
Yes, that's a Lewism. Yep.
Okay.
You see a lot of end statements. I'm always telling people, you know, the end is near, because no matter where you are in the code, the end is near. Okay. So now we probably want some vertical motion, right? Okay. But let's imagine for a moment that we have vertical motion. We're going to have the same problems that we had with our horizontal motion, right? So we want the ball to also bounce on the bottom and top. So what do you think we're going to use for that, guys? And gals. I don't want anyone to feel
Why?
y, yes. Okay. So we're going to say if v.y is greater than what? Height. Then v.dir equals v.dir times -1, which doesn't make much sense right now, but we'll get into some fancy trig. Who here's good at trig? I sure hope someone's good at trig here. We are doomed. We are in trouble.
You're good at it, so.
Okay, so we're going to say height, and then if v.y is less than 0. Now, in most graphical systems, and love to use SDL, which is OpenGL, 0, 0 is the top left, not the bottom left. Okay, so being negative y means 0 above, being positive y means 0 below. And that's an important difference because you look at stuff and be like, everything's upside down, and then you'll be reminded that I said this, and you'll go, oh yeah, that was the point he was trying to make. Okay? So now we've got this going on. Let's make it so our ball, just to test this out, we're going to make it so that it's going to be moving on the y-axis instead of the x-axis. Right? Okay, so is it going to work? Yeah. Okay. Now, we kind of have a misnomer in one of our variables. We're saying direction, but that really isn't direction. What is it's what?
Velocity.
Velocity, right? So let's change it. I'm gonna really just be simple. Velocity is too much of a pain for me to type. I'm gonna say speed, so I can just keep hitting the E button and we're good. So I'm gonna say going to change this so it says speed. And there's probably a find and replace thing. I'm sure there is because I'm using Sublime and it's a great editor. But I was coding it for this morning, so I can't remember anything. Okay, so we got that, and we need to say speed. We're going to run our game and make sure we didn't break anything. I don't think we did. We should be fine. There we go. Okay, so now we have speed, but we still need that direction. We still need it to move somewhere, right? So if we go ball dot direction equals, now who here knows what a radian is? No one know what radians are? Okay, what's a radian? Someone over here.
It's kind of like degrees. It's
Yeah.
like 2 pi is a full circle.
Yeah, it's a way of representing degrees. Exactly. So can we actually use, can I use this whiteboard? Or would they be terribly offended if I did that?
I think you're good.
We're good? Okay. So we have the world's worst circle because I'm short. Okay. And we've got pi and negative pi and 0. Okay, so pi 3.14, I can't sound smart by saying more decimals. As it moves from pi down to 0, a rotational change, and then as we move from 0 to negative pi, a rotational change. Okay, so pi and negative pi are effectively the same, which can create some really hilarious situations when you're crossing over. I was making a game and a ship was flying and it was trying to turn and it was going to cross this seam, and so it always took the long way around. Okay, but we're not gonna deal with too much of that. But it's important to know what radians are because that's how most applications, most game frameworks speak about degrees, speak about angles. Okay, so we're going to say that its direction can start out anywhere between. Math.random. It can start out anywhere between negative pi and positive pi, right? But we want to have some granularity, so this is so that we don't lose granularity. Okay, so we're actually saying negative pi times 100 between positive pi times 100 as our random number, and then divide that by 100 to get our actual direction. Does that make sense, people? Or did I just confuse everyone? First time I did this, I confused myself, so don't feel bad if you're confused. Okay, but, and then love.math.random, you could just say math.random, which if anyone's done Lua, you know that's perfectly valid. Trouble is, math.random isn't always random. Like, yes, it's random, but it's always random in the same way unless you give it a new seed. So unless you want it to always start the same way, sure, it's random, but predictable. Love.math.random will inject a new seed when it's used. So it's more random than the standard Lua random. Okay. So now, if I run the game, what's going to happen? Nothing, because we're not using the direction yet. That was a trick question, guys. But if I look in our ball object in Lovebird, you can see that we have a direction, negative 0.28, which would be this way, a little bit. Yeah. Okay, everyone with me on that? Okay, so who knows the trick where you can use magical sine and cosine to get the direction? Anyone know that? Or do I need to reference my code because I still don't have it memorized? What?
Sin x is y, cosine x is x. I don't know exactly how you get it, though.
Okay. Well, we're going to need two things. We know we're going to need two things here. So we're going to need an x direction. Oh. And we're going to need a y direction, right? This is how far down we're moving, or how fast down we're moving, or up we're moving, how fast left or right we're moving. And that's going to be built off of our ball direction. Oh, there it goes. I'm usually on Linux, and my shortcut key to move things up did not work here. Maybe this one will. Nope. I'll just have to do this then. This is terrifying, guys. Okay. So your X direction. Oh, I need to move speed above it too, because if I'm going to reference it, it's got to exist first. Okay. Our X direction, I believe, is math.sign, ball direction, times ball.speed. I think that's what it is. If anyone here actually knows math, please correct me. Okay. But now we're going to move this in two directions instead of just one, right? So we're going to say our v.y equals v.y plus v dot, what is it, y speed? Xdir and ydir. Everybody didn't name those well, I apologize. Ydir times dt, and v dot x equals v dot x plus v dot xdir times dt. So everyone see what's going to happen here? So let's see if this actually works, because we should see the ball going off in a random direction. Look at that. Now, it's not being caught by our other handling, right? Because we're checking speed, we're not checking what's actually going on with the ball. But you saw what happened. If we launch it again, it should go in a different direction. A little bit different. Come on. Give us a really good different direction. Look at that. Hey? Okay, so we got the ball going in different directions. We need to change our constraints a bit. And what do you guys think we need to do to change our constraints? Because we're just checking, let's change our speed. But we're not using speed anymore. Right? You see that our movement is not based on its speed at all. All it's based on is its x direction and its y direction. So what if they leave the right boundary, we just reverse the x direction? If they leave the left or right side. And if they leave the top or bottom side, we just do the y direction. You guys think that would work?
We've got speed directions instead of birds.
Oh yes, you're right. Okay. And this is why I ask if it'll work. Not because I want to know if people are paying attention, but because I want my code to work. So, okay. So how does that look to you guys now? Think we'll have a ball bouncing around? Moment of truth. Oh, there we go. I could feel the anticipation there. Did you guys feel the anticipation there? It's like, is this going to work? Okay. And now we just need to test the other side. Ooh. Okay. Now let's have some fun, just because it's always nice to see actual things here. Let's take our speed and increase it by a factor of 10. Okay. We have one of the first screensavers of Windows 3.11. Okay. But you guys can see that now we have our boundaries. We have our ball moving. So what's next? Oh, what happened?
I got stuck at the top and then flew off. We found the bug.
We may need some more air handling. That's probably because my speed was too high. It probably differed and my frame rate fluctuated just enough that it couldn't get back in. So it kept reversing and went, okay. Yeah, when you're doing game dev, that's actually part of the fun, is seeing all of the weird things that happen that you don't expect. Like, did anyone play Hexapod Defense Force last year? Here? It's like Space Invaders. There's these aliens that land, they attack you. I had a bug whenever a bomb went off, they'd all moonwalk away from the bug. Or the bomb. It was hilarious. We're like, we have no clue why this is happening, but the bomb would explode, we're like, whoa. So, funny stuff happens if you're doing game dev. I'm not going to worry about trying to make this perfect. Okay? It was probably because the frame rate fluctuated while it was out of bounds, so it couldn't get back into bounds properly. And that's really because the order we're doing things here isn't really the best way, but it's simple and it illustrates the point. Okay, so now we've got our ball bouncing around. What do we need now? paddles, or as I like to call them, players. But paddles work too. So, okay, and I've already stubbed out this function that says I'm going to add a player. Now the player, believe it or not, is very similar to the ball. All right? The player has what?
X and Y positions.
So I'm going to make a spot to temporarily build out this player. I'm going to say player.x equals, we'll say 100, just because, why not? Player.y equals 100. What else does a player have? Control, right? So we're going to say player.upKey equals upKey. I think he cheated on that answer though. Because you were looking at my function prototype there. Okay. There's another thing that a player has.
Physical form?
Height and width, yes, physical form, right? So we're going to have... Okay, so we'll make it like 100 tall and
10 wide?
10 wide? 10 wide sounds good. Okay, and then we need to do a table insert. We need to put the, just like we did it for the balls here, we need to say that into the players table, we will place the player. And then we probably want to draw the player, right? If anyone doesn't understand what I'm doing, please speak up. I was going to start typing gibberish, and then if no one spoke up, I was big. Okay. Okay. And then what do you think is going to happen? What? I heard it.
Get it all clear.
Oh, okay. I didn't know where it came from, so I was like, who's speaking? Okay. Yes, it'll draw the player. So if we go here, we run it, we will not see a player. Why aren't we seeing a player? And believe it or not, I didn't know we weren't going to see a player.
Add the player somewhere.
We need to add the player, right? We initialize stuff. Remember, we've got these different steps we got to go through. We need to initialize the player, right? So I can actually use lovebird, and I can do add player, and I'll say the up key will be up, and the down key will be down. Holy cow, look at it. Okay, so we got a paddle now, right? And we were able to add that just by arbitrarily calling add player, right? But we don't want to say necessarily, let me exit that. We don't necessarily want to always put the player in the same spot and whatnot. So we're going to put some logic into our player initialization to determine is this the first player we're adding or the second player. Okay. But let's add the player up here. Just like I called in lovebird. That's what's so nice about lovebird, you can just like run your function and see if it works. So now when we run it, we'll actually have our player. Okay. Looks like the ball bounced off him. The ball will just pass through him, but it looks nice. So that's all that really matters. Okay. Now we need to make the ball bounce off of this player, right? So how do you guys think we're going to do that?
You're going to have strength here?
Sorry, I heard mumbling. Okay, two people were speaking, and I think you both were right. So
reference the player's position relative to the ball.
yes, yes. We need to say, is this ball contacting the paddle? Right? Is that what you said essentially?
I'm adding another if statement here. So.
Yes, yes. That's the method we'll use. So we had our pseudocode, which was they need to interact, and then we have our actual code, which is yes. We're going to use an if statement. So we're going to say if v.x is, how are we going to do this? What do you guys think? I think we need another for loop, because we need to check both paddles, right? So I'm just going to name a new variable for kkvv. I could say for player, index, and player. in I pairs players do end. So we're going to be comparing the ball's position with the player position, or the paddle or whatever, yeah, right? So we're going to say if v dot x is less than what? Well, we'll probably do greater than first. It's greater than what? I'm not moving on until someone says it. What is v dot x?
The wall, right?
The ball, right? The ball's x position. So if the ball's x position is greater than the player's x position, right? But not just that. It needs to be within that, right? He's like this. Okay. It's greater than that, and the ball's x is less than the player dot x plus the player dot width, right? Because we need to be in that slice, okay? Then what's going to happen? What are we going to do?
We basically still what we had up there.
Yes, we can. Okay, this.
Can we just functionize that, or?
We could. But I mean, we're just trying to hack together something real quickly. But yes, the proper method would be, we would actually want to do it like this. We would look up here and we would say, this condition can happen in multiple scenarios. And we would end up checking both in one shot. But I'm just trying to go through one thing at a time. You see what I'm saying? Yes. Okay. Then we do that. And then we should also check the y, right? I hope you guys are enjoying this. Are you guys enjoying this? Am I doing okay? Mm-hmm. You're not just saying that to make me feel good about myself. It helped me deal with my terrible self-esteem. Okay. So now it's going to look through each player and it's going to see if it should be bouncing off of it. Right? Now this, keep in mind, this is going from the center of the ball. This is not going from the edge of the ball. Okay? I don't want to go through the math to figure out, corners and all that kind of stuff. So we're not going to worry about that for now. There's actually some libraries that would help with that. And Love has a built-in physics engine built on Box 2D that can do some really cool stuff where you can make it so the ball's going fast enough, the paddle gets knocked out of the way, and all sorts of fun stuff you can do. But let's see if this works. This might take a little bit. Let me speed it up. Or let me just cheat. I'm going to go here. I'm going to say, you know what? Our first player, his height, he's going to be at an advantage here. There we go. This is how I like to play. Okay, so let's see if this actually works. Yay! Okay, so now if we add another player on the other side, then it'll work, right? But let's do a what's that game where you hit the ball with the ball and it comes back and you hit it again?
Racquetball?
Racquetball or squash, isn't it something called squash?
Oh, yeah. Squash.
Yeah. Okay. We will call it racquetball. Okay. Let's just make it so we can move the player first, and then we'll work on adding our other player, and then we will have a Pong of sorts, and we will make it just a few minutes over schedule. So, but hopefully this is teaching you guys how this works. So, in our update, that's when you need to be checking if the paddle should be moving, and we probably want to check if the paddle moves before we're calculating all the other stuff. So we need to say for K, V in I pairs players do, because I'm iterating through the players again. This is wasteful, but with up to 2 players, I think we're okay. So we can do if love.keyboard.is down v.upkey because we're checking what we save for its upkeep, then what's going to happen? Well, we change the player Y, because they're going up and down. Although that would be a very interesting one. So b.y equals, and what are we going to do with the Y? Plus? Yeah, it's backwards, exactly. Okay, so we're going to say 100 times dt. Okay, and then we need to say else if love.keyboard. And the Love website goes very thoroughly through all of the API. But this is like just the core stuff. We're supposed to teach you guys the core stuff. Y plus 100 times dt. So let's see what we've got here. And then I think we're going to have to call it the end of the presentation. Holy cow, things are moving slowly. I think our ball's direction is not quite where we're wanting. Let's see. Go down to our ball speed. I'm going to speed it up a little bit just so we have the scenarios. And I think we've got a bug in our code. Okay. So we've got kind of an interesting bug here.
Yeah.
What's happening?
You have a logical or instead of a logical.
Oh, look at him go! Look at him go!
Is it detecting when we hit our paddle's y-axis or our paddle's x-axis?
Well, let's read through this. So it moves the ball, and then it says, go through each player. And if my x is greater than the player x, and my x is less than the player width thing, then I'm going to reverse. And then we have an else if. We need to be saying, let's see here. And we're at the very end, so I feel all pressure to try to finish it. Yes?
Your else if functions as a logical or. You need something that functions as a logical and.
Okay. So what do we change?
I don't know. Can you put an and in your if statement? Can you say if bx is greater than player x and bx is less than that part, and then and
Okay.
the b.y statement and it up together with that?
So we need to take this out, like so, and up here go, right?
I don't think you need to change the Y here either. You only need to change the X.
Yeah.
And then we'll run it, and then I think we're done. Let's see if it works. Okay. Now, there's other things we need to add. For example, the player can leave off the bottom. The player, if the player is skilled, like I am, can trap the ball. Oh. Okay. But we couldn't get through quite all of Pong, but I hope you guys felt like this was enlightening. Do we have any quick questions before we have to depart? I'll be down by the booth. Everyone knows where my booth is, right? Okay. I can answer more questions and all that jazz. Thank you so much.